Okay, take out your workbook. Those who just joined us, page 11. Huh? Mr. Chia stole your workbook. Can you go back and tell him to return you your workbook? Now we have our all-star team back.
Where's Aryan though? Where's Aryan? Why he chose to stay? Elias, tell Aryan come. Why he run like that? Why he run like that, Joe? Ask him fix his running.
Okay, hey. Ari, why are you still talking? I want to talk already. Xingning and Mia also. Okay. There is one thing very important, that when you see equations, you must have that idea. If you don't have that idea, later you go inequality, you will have a difficulty also. Okay, so this one, get it very clear now. When you see an equation, this equation is actually like a comparison. Kelly, this equation is like a comparison. This equation is telling you whatever that is on the left hand side of the equal sign is the same as what you have on the right hand side. This is the most basic thing that this equation is telling you. Okay? Everything that you do after that starts from knowing this. Equal sign, equation, everything on the left is the same as everything that is on your right. You must know this very clearly first. Okay? Then I told you a lot of time, when you have an equation, when you want to solve an equation, you are finding what is x. Solving of equation or solving of this equation means you want to find out what is this value of x. And what is this value that will balance, that will really make your left and the right the same. So if they are asking you what is x, definitely your final answer is going to be x equals to what? That is the whole idea behind solving. Okay? So some of you managed to get the first step. Whenever I see a fraction more than one term, number one thing I do, bracket. Remind myself, my 4x belongs with the plus 6. Together they form the denominator. Okay? So this is this equation. Left hand side got this fraction. Right hand side got this number.
Aryan!
Come in, come in. Go, go, go.
Oh, hell no. Aryan, please, Aryan.
Okay, those that just come in, take out your workbook, turn to page 11. Hey, y'all come here because you're always talking in Mr. Chia's class. No.
I got option today.
Okay. Then if y'all come here, continue to talk, then I don't know send you to whose class already. Okay, workbook, page 11. Quick, quick, quick. Page 11. You do already, listen to mine. You all may have done already, listen to my explanation. Follow my steps. Page 11. Question 3C. Okay. Ever since we face fraction, I already tell you when your numerator, denominator got more than one term, go and add the bracket first. No change. This one is consistent one. You will continue to do this until you Sec 4. Okay? Then now, when I compare what I have, the equation, and the final equation that I want, my x is a numerator. My x is a numerator by itself. Okay? So from the very first equation that I'm given, I want to continue to write equation. With this equation, I want to write the next equation, until I get to my answer. Okay? So, if I look at this one, my x is inside the denominator. I don't want. My answer, my x is numerator. So I need to bring this whole denominator, make it not a denominator. Or make the left hand side not a fraction. Which is why I need to multiply. I need to multiply the entire bracket. Okay? Equation. Left hand side is the same as the right hand side. If I want to write the next equation, to have the left hand side still equals to the right hand side, I must do the same thing. Okay? So the result will be this bracket that I multiply will cancel with this denominator. I purposely choose the same thing one. So it will cancel. I no longer have a fraction on the left. Then on my right, this bracket appear here as a multiplication. So I want to continue. I want to make x alone. Remember, that is my final answer, x alone. So from here, I want to write the next equation, but my x is now inside the bracket. My x term, the 4x, is together with plus 6 one. They are inside the bracket. So like that, I cannot work with it. Okay? There are two ways to continue. One way, I expand. I multiply my negative 7 to both the 4x and the positive 6. Like that, you will be able to continue because you will have free your x from the bracket. But when I see this, 21 and 7, 21 can be divided by 7, right? So instead of opening the bracket, instead of multiplying, another way to open the bracket is I divide both sides by negative 7. Once I divide both sides by negative 7, this one become 1. Then 1 times of this bracket means it is just the bracket itself. So I divide both sides by negative 7. I will have 21 divided by negative 7. Then my right hand side, I divide by minus 7 also. So minus 7 and minus 7 cancel. I'm left with 4x plus 6. This is another way to remove the multiplication. I bring this minus 7 to the other side, divide. Then I simplify. Negative 3 equals to 4x plus 6. Now it is alone already. I no longer have a fraction. I don't have any multiplication, so I can remove the bracket. Then finally, I want x only. Meaning, this 4x and this plus 6. I want my 4x to be alone. I want this 6 to go the other side. So I have minus 3 originally on the left. I write it down first. I never touch it. But I don't want the plus 6 on this side. So I need to minus 6 to let it disappear. That's why I need to minus 6 equals to 4x. So you will notice, left hand side is left hand side. I keep going left hand side. One, continue left hand side. Right hand side, continue right hand side. Minus 3 minus 6, simplify. When I reach this step, there are two ways to continue also. One way, I divide both sides by 4. If I divide by 4, I can get 1x already. This is what I want, ma. X is negative 9 over 4. So if I can get x is negative 9 over 4, I switch their places. Because finally, I want x to be on one by alone on the left. So this one, I just switch their left and right. I don't change the sign. X is still x. Negative 9 over 4 is still negative 9 over 4. I don't change their sign. I just left go to right, right go to left only. Then this is my final answer. Now Nabila, can? Because just now you stuck at first step, right? So the continuation is to divide both sides by negative 7. When you cannot divide nicely, you can do expansion, no problem one. See whole thing, like that. Can see or not? Your pen doesn't work. Go and bite your finger until you use your blood to write. Hey, today we have a lot of things to cover. I want to cover your homework. I want to cover another different kind of fraction. Then I want to start with inequality. I want to finish inequality today. Yeah. Okay, done? Done? Not yet. Done?
My job, I just showed them.
Done,
Yeah.
Okay. Next one, the idea is the same one. Okay? That I have an equation. Left and the right are the same. So, I want to finally solve the equation. Means finally, I want to know what is x. So, my answer is definitely x is what number. So, I want to put all the numbers on one side. Put all the x on one side. So when I look at this, again, I go and find my x. My x is a part of the denominator. My x is part of the denominator inside the bracket. Like that is not what I want. So I want to multiply the denominator. Okay, then this time happen again. 45 is 5 times 9. Then it can be divided by 9. No? Divide by 9, I can have a nice number. So I straight away divide by 9 first. (45) divided by 9 is 5. Okay, so my left hand side become like that. When I divide by 9, I can cancel away. My right hand side divide by 9 will be equals to 5. So actually I am dividing by 9, dividing by 9. Okay, then I want to keep my x term on one side, put all the number on the other side. So my negative 2x is on the left already. I keep it on the left. I want the 1 to disappear. 1 is at the front. So when it is at the front, by default, there is a plus 1 that we never write. 1 is actually positive 1. So it is actually plus 1. So when I make it go to the right, I need to minus 1. Minus 1 to cancel the plus 1. Okay, so this one we usually don't write the plus, but it is a plus. So I will have 5 minus 1. Okay, what I do is actually I minus 1, minus 1. That's why the 1 disappear. That's why the minus 1 here. Okay, Then I continue to simplify. 5 minus 1 is 4. Then finally I want to have 1x. So now I have negative 2x. To make the negative 2 go away, I need to divide. I divide by negative 2. Then my negative 2x can become x. Why? Okay? Then solved. My x is equals to negative 2. Can Arik finish means everyone finish. Can I move on? Okay, I want to touch on another 2 questions. Okay, I get started, then you all continue to finish at home. Part F. Again, my left hand side is just this 6 over 7. 6 over 7. Then my right hand side, this time round my right hand side got a fraction adding a number. Okay? So this time round a bit different from your previous one. Your previous one only a fraction, never plus a number. So one way we can start first. When I see this, I must also be thinking, finally I want my x, but now my x is denominator. It is inside the bracket, I cannot use. So one way, this fraction contains the x that I want. This number, hello, listen, Arik. This number don't have x. So I want this term in the end to be by its own. So I can bring this plus 1 across first. I keep my x term here. Then my 6 over 7 I never touch. But I can bring this also just number. It is just number. If I bring it across, I can have my x, which is inside the bracket, still being isolated. Then this is just 2 numbers. I can key this inside calculator or I can do the subtraction of numbers myself. 6 over 7 minus 7 over 7. Then I will have negative 1 over 7. Oi! You all come back here to talk also, then really, where to send your next? Next one is here. You see all these locker, you all can stand here, put your book, and then listen to the class. I want to use another trick. Remember, my negative can put on top, can put beside, also can put at the bottom. They will mean the same thing. Negative 1 divided by 7 or positive 1 divided by negative 7, they all will be the same thing. So here, I will put my negative instead of on top, I will put below. Later will be easier. Okay? So I would rather put my negative sign below. Then next, I want to make my denominator go away, Arik. What do I need to do? Times the bracket itself. Okay? So, when I times the bracket, it will cancel, it will come here as the numerator. At the same time, I don't want this denominator also. So I can multiply negative 7 to cancel away this denominator. Then when I multiply negative 7, it will come over here to become negative 7. Because I multiply negative 7 to both sides. Then here will be 1 times negative 7. When I multiply this across, this is 1 times the bracket. I multiply negative 7 to cancel away the negative 7. Then when I multiply negative 7, I need to multiply negative 7 to the right also. At the same time, I also multiply this bracket. Okay, so my negative 7 cancel with the negative 7. Then I'm left with this bracket multiply 1. Here also, this bracket cancel with this bracket. I'm left with 1 multiply negative 7. Yeah, the result is like a cross multiplication. Huh? Confusing? Okay. Sorry, if this is confusing, I do another more step first. Too late. I erased already. Hello, hello. Why are you dancing suddenly? Wake it, Arik. Okay. Hey Elijah, I want to move you already. That seat looks very lonely. Okay, listen. Okay, if just now too confusing, then still going by my normal way to do, I will multiply this bracket so that my x is not a denominator. Okay? After I multiply this bracket over, Then I still don't want a fraction. I don't want there to be a 1 over 7. So if I don't like this 1 over 7, I can make it disappear. I make it disappear by multiplying 7. When I multiply 7, 7 can cancel with this denominator. Okay? But if I only multiply 7, I still have a negative 1. So might as well I multiply negative 7. So that the negative also disappear. Negative times negative become positive. Positive 1. Then I no longer have this fraction at all. Okay? Then I'll be left with x plus 6 equals to negative 7. Can? Okay? Then finally, I take my 6 go the other side also. Then I will have my answer. Can? Arik, let me know when you are done. Okay. Okay, part E will be your homework. Part E will be your homework. I want to move on to the next page. Next page is easier. Yeah, next page is easier. I know, I'm waiting for you. Waiting for you. Waiting for you. Waiting for you. Come back to. Okay, done? Okay. Part E. Hello, hello. Part E is your homework. Okay? Then we go to the next page. Next page is easier. Okay, next page, part G. Wait, how do we start? No, even before that. Yes, bracket and bracket. My x is stuck with the plus 7 in the numerator. My x is stuck with the plus 9. Okay? So before I can remove my x, put it on one side, we get. I must have the bracket first. Then from there, my next step is, I don't want this bracket to be in the denominator. Okay? I don't want the bracket to be the denominator. What do I do? Yes, Amira. I don't want this bracket to be in the denominator. If I only look at the left, what should I do to make the denominator disappear? I asking Amira lah.
My name is Tiara Amira.
Tiara Amira. Tiara answer already, Amira. Amira, you see here, if I have this fraction, can I multiply something to make the 3 disappear? I multiply by what will make the 3 disappear? Then 3 and 3 will cancel what? Correct. Okay? Hey, listen, why so noisy? So Amira, this time round, the denominator is not 3, the denominator is a bracket. What do I have to multiply? What can I multiply to make this bracket disappear?
I know multiply itself.
Okay, come on. 2/3. I want the 3 to disappear, I multiply 3. If I have 2/5, I want the 5 to disappear, I multiply 5. Okay? So this time round, if my denominator is a bracket, I multiply the whole bracket.
X plus 9.
Yes, very good. Can? Okay. Xingning, now my right hand side got a fraction also. If I don't want the 19, what can I do? Yes, times 19, very good. Okay? So at the same time, hey listen, Elijah. Because I want to multiply this bracket to the left, I want to write the next equation. Left must be equals to the right. So if I multiply this bracket to the left, I need to multiply the same bracket to the right also. And then because I want to multiply 19 to cancel this on the right, my left also need to multiply 19. Like that, then I can write the next equation. For the left still equals to the right. Okay? So what is the effect? The effect is, I purposely multiply this bracket to cancel this bracket. I take another color. I purposely multiply this bracket to cancel this bracket. I purposely multiply this 19 to cancel this 19. So on my left, I am left with 19 multiply this top numerator. On the right, I am left with 15 multiply this bracket. I make it like that one. So the result looks like my denominator from the left is multiplying the numerator on the right. My denominator on the right is multiplying the numerator on the left. Okay? So my 19 multiply the numerator. My denominator multiply this numerator. It looks like there is a cross like that. My denominator multiply this numerator. My denominator multiply this numerator. Okay? So a lot of tuition teacher or other teacher, they tell you, you see two fractions equals to each other, you straight away cross multiply. Numerator multiply denominator. Numerator multiply denominator. But I don't like you all to just memorize this thing because you will make mistake. So know that you are multiplying to cancel away the denominator. You are multiplying this to cancel away the denominator. Why cannot what? What? I cannot hear you.
Where can I find a math tutor? After.
Me lah.
Teacher get up.
Ah.
Teacher get up.
No. Okay.
So 115 free eh. So it's halfway though.
Then remembering that to solve an equation, you want x equals to something. But right now my x is inside the bracket. My x is inside the bracket. I cannot use the x. So I need to do my expansion first. I need to do my rainbow method first to free my x from the bracket. Left hand side, do my expansion. Right hand side, do my expansion also. I will end up with 4 terms. X term here, X term here. But by now you all should know I want to solve means I put all my x term together. So my 19x stay here. My 15x, I want it to go to the left also. So I need to minus 15x. My 135 is on the right, I don't need to move it. My 133 is on the left, I want it to go to the right. Because I want to put all the numbers on one side. Put all my x on one side. Then I simplify. 4x equals to 2. Where I get the what? My 15x is on the right. I want it to disappear from the right. I need to minus it. When I minus it, I minus something on the right. I need to minus the same thing on the left. That's why I purposely minus to make it disappear. It will appear here as minus. Same, 133 will appear here as minus. Okay? Answer 0.5. Very good. Leave it as fraction even better. Just write half. Okay? We do one more. The rest also your homework.
Class end
150.
Aiyo, so long. I hope it ends now. I have a
Arik, this time Jarius done already leh. You done already? Yeah.
Wow. Alright, saying Jerry started a bit better with the monkey. Bad friend.
Okay Arik and Jarius both done. So I think everyone done. Amir, what's the first thing to do, Pat J? Yes. Then what is my next line of thought? Times. I don't want the denominator, so I need to multiply away the denominators. Okay? When I multiply the denominator from the left, it will end up to the right as numerator. When I multiply the denominator on the right, it will end up as numerator on the left. Okay? So, okay? I multiply the denominator on the left, make it go away. Then when I multiply, it will become multiplying on the right. Multiplying to your numerator. Similarly, I multiply the denominator on the right. It will go to the top, to the left. Because when I multiply, It cancel out. Then when I multiply on the left, it go to the numerator. Huh? Oh. Oh, yeah lor. Jairus so lousy man, need you to teach him.
What? What?
Oh. Okay. Arik, what's the next thing to do? I want x to be on one side finally, but now my x is inside the bracket, Yes. So I need to expand to free the x out. Nabila, what is the next thing that I want to do? What is the next thing I want to do? There are 4 terms now. 8x got x. Minus 44 got no x. 10x got x. 24 got no x. Plus what? My final line will be x equals to something. So from here to here, I will want to put all the terms with the x on one side. Okay? So that is the next thing you want to do. Put all the terms with x on one side. 8x is on the left, I don't touch it. So I want to move my 10x to the left also. When I move my 10x, it will become minus 10x on the left. My 24 is already on the right. I don't need to change anything. But this term, minus 44, got no x. The no x one, I want it to be away from the x. So it will come here as positive 44. Can, Nabila? Put all the x on one side, put all the number on the other side. Okay? 8x minus 10x, negative 2x. 24 plus 44, 68.
One away, bro. One away.
Then I want x. I don't want negative 2x. I need to divide by negative 2 on both sides.
Please.
Follow so far? Okay, come back by 105. I want to start by 105. Huh? But Mr. Chia don't want you. I'm telling him the fact. Yeah.
He's gonna cry.
Martin, don't cry. Why you cry?
Someone just said.
You don't need your textbook or workbook now. Just listen. Okay. Almir, still talking. Okay. Arik.
Give me back my hammer, bro.
Hello. You want to move there again?
Oh, this is my hammer. What I do?
I don't know. Why do you have a hammer now?
Someone told me that Wing was century. It's 15 this year. Somebody told me that Wing was century.
I want to start inequality. Okay. So far, I have been stressing that what do you need to know for equation? An equation got an equal sign. The equal sign will divide this line into your left hand side and your right hand side. Okay? Then equation, the name, the equal sign is telling you already. Left is equal to the right, or left is the same as the right. So whatever I have here is the same as whatever I have on the right. So there can only be one value. What is x? X is 9. Okay? Then we go to inequality. Equation means equal. Inequality means not equal. So when it's not equal, Almir, when it's not equal, we learn another few symbol. Okay? One of them is like that. This side, the left, open up. Can you see this side is wider? Then when it goes to the right, it is just one dot. So this side is bigger, this side is smaller. Okay? So what this sign means is, again, we still have our left and our right. Whatever is on the left is bigger than whatever is on our right. So if now I still write this, it means that my x is larger than 9. X is not equal, that's why we call it inequality. X is larger than 9. Okay? In another words, Orel, x must be larger than 9. It means that Jingyi, still talking. Hey, it's their choice to stand there. It's your choice to look at them. They're so ugly, you still want to look. Okay? Pay attention here. So x must be larger than 9. If you think, what are the possible values of x? X can be what? X can be 10. Because 10 is a number larger than 9. X can be 11. X can be 12. X can be 13. Okay? So this inequality is telling you x can be 10, x can be 12. Can x be 8? Cannot. So this inequality is also telling you x cannot be 8. X cannot be 7. Okay? So this is what this inequality is telling you. Unlike your equation is telling you x must be 9. There is only one possible value. But when we have inequality, x can be 10, x can be 11, x can be 12. X can also be 9.1, 9.2, as long as it is larger. Okay? Then, we have another sign. This time round, this side bigger than this side is smaller. So in English, we always read from the left to the right. So this one, we read it as x larger than 9. This second line, we read it as x smaller than 12. It means that my x must be smaller than 12 because of the inequality sign. Okay? So actually, inequality is like that only. If you understand this, then later we see how we deal with the questions. Okay? Can? Okay, then let us look at your workbook. One C. Page 15. Okay, when we read the question, they tell us x is an integer. X must be a whole number. So this first line tells us x must be a whole number. Okay? Then when we look at the inequality, when we look at this inequality, they put three things together, but we read them a pair at a time. So like that. First, I look at these two values to compare. X must be larger than -4. Okay? So from there, what are the possible values of x?
-3.
Okay? Okay. So if I just look at this line over here, if I have a number line, 0, -1, -2, -3, -4. Here is 1, 2, 3. My x must be larger than -4. Number means we go to the right is bigger, so my x must be larger than -4. So my x can actually be -3, can be -2, can be -1, can be 0, can be 1, can be 2, can be 3, so on and so forth. Okay? So it can be all these numbers. But there is another line, or within the same line, they tell me x must be smaller than 3. Then why this smaller sign got another line? Okay? When we have this sign, it means x can be smaller or equal. It is not restricted to smaller than. They are telling us x can be 3. Okay? So from here, we are limited already. This another condition. Yellow one is the condition 1, blue is the condition 2, and then it must satisfy both conditions. Okay? So from the yellow, x can be -3, can be -2, can be -1, can be 0, 1, 2, 3, can be 4, can be 5 also. But because of the blue say x must be smaller or equals to 3. So it can be here, 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 it can be here. But right now I have to satisfy both. So my x can only be from -3 to 3 only. -3 to 3. Okay? And they still give me one more condition. X cannot be -2. Okay? So this one cannot. Then they ask us to list down all the possible x. So x can be -3, cannot be -2 because of this condition. X can be -1, can be 0, can be 1, can be 2, can be 3. Depending on the sign, x is larger than -4. X is smaller or equals to 3. We read it from the left, so -4 is smaller than x. So it also means x is larger than -4. Yes, negative 3 is bigger than negative 4. Numbers go bigger when we go towards the right. Oh, following? Can? Larger than, smaller than. Okay? Question 2. List all the prime numbers that satisfy this condition. So what does this condition tell us? X is smaller or equals to 0. Okay? Sorry, X is larger or equals to 0. It can be equal, it can be larger. But X must be smaller than 20.5. Okay? So there is, X must be between these two numbers. Can you see X must be between these two numbers? So what are the prime numbers? The prime numbers start with 2, go to 3, go to 5. We always start with 2. Okay? Then the next, all the even numbers are not prime numbers already. Because even numbers can divide by 2. So 2 is the only even prime number. Because 2 can only be divided by 1 and 2. 3 can only be divided by 1 and 3. If I go to 4, 4 can divide by 1 and 4. 4 can also divide by 2, so 4 is not a prime number. Okay? So all even numbers are no prime numbers already from here on. So 6 we don't need to list down. 6 is even. 7, prime number. 8 is not prime number. Then we try 9. 9 can divide by 3. So 9 is also not prime number. 10 is even number, so not prime. So the next one, 11 already. 12 is even number, so not prime. So the next prime is 13. 14 can divide by 2, so not prime. 15 can divide by 3, can divide by 5, so not prime. 16 even number, not prime. 17 prime. 18 even number, not prime. 19 prime. If we want to continue, 20 not prime. 21 can divide by 3, not prime. 22 even number. So the next prime number is 23 already. But the inequality tell me X must be smaller than 20.5. So all these numbers are acceptable. 23 is not acceptable. So don't have. Because X must be smaller than 20.5. Can? Follow so far?
Yeah.
Okay, now coming to the question 3. We see this word again. Solve. Okay? Arik, when we are solving equation, what are we asking? What is your answer if I'm solving equation? Okay. If I am solving equation, my 8x equals to 32. 72. If I am solving an equation, 8x equals to 72. Solving means I write equation until x is alone by itself. Okay? Then to get here, I need to divide by 8 on both sides. Then I get x is 9. Okay? So when I'm solving inequality, this time round, this is an inequality. It's not equal. They say 8x bigger than 72. So when I'm solving, Actually the same one. I want to finally have x on one side, all the numbers on the other side. That is called solving. Okay? If 8x larger than 72, I want to get from 8x to only 1x. I also same. 8x divided by x. Sorry, 8x divided by 8. 72 divided by 8.
I missed. I don't
Leave it. You don't need it now.
Okay.
Okay? Why? Imagine if now I tell you 2 is bigger than 1. Correct or not? Correct, 2 is bigger than 1. If I multiply the same number to both sides, if 2 I multiply 2, it will become 4. 1 I multiply 2 will become 2. Is the left still larger than the right?
Yes.
Okay? If I multiply 3, 2 multiply 3 becomes 6. 1 multiply 3 becomes 3. Is the left still larger than the right? Yes. Okay? So, when we are multiplying any number, positive number, the sign will be still the same. 2 will still be bigger than 1, 4 will still be bigger than 2, 6 will still be equals to bigger than 3. So the reverse is also true. If my 6 is bigger than 3, I divide both sides by 3. 6 divided by 3 is 2, 3 divided by 3 is 1. My left will still be larger than the right. So whenever I'm multiplying a positive number or dividing a positive number, the relationship don't change. Left still larger than right, left will still be larger than right. If I started with 1 smaller than 5, I multiply 2, 2 and 10, it will still be smaller than. Okay? So I don't need to change any signs. Okay? But okay, one more relationship.
Me and Amir.
Okay. Okay, listen. If I start with 2 and 1, 2 is larger than 1. If I add number, if I add 5 to both sides, 2 add 5 becomes 7. 1 add 5 becomes 6. Which side is larger? So the relationship don't change. Even if I add 100, then I will have 102, 101. I add 100 to the original. I add 100 to the original. My left, is it still larger than right? Okay. Can? So whenever I'm adding numbers, the relationship don't change. If I add the same to both sides, the relationship will still remain. Larger than will still be larger than. Okay? If we were to subtract numbers, 102 larger than 101, I minus 100, 2 minus 101, 2 will still be larger than 1. So the relationship don't change. Okay? So plus and minus settle. The only time when the relationship change, yes, how to change the relationship? I start with 2 and 1. If I multiply 2 become 4 and 2, the relationship don't change. But if I from 2 and 1, I multiply a negative number. Let's say I multiply negative 2. 2 times negative 2 become negative 4. 1 times negative 2 become negative 2. Now, is the left still larger than the right?
Oh, the right is bigger.
Jingyi,
对吧？
why are you looking at your PLD?
好
I don't care. I told you you don't need your PLD now. I only need you to listen. Okay. So from 2 and 1, 2 was larger than 1. If I were to multiply negative 2 to both sides, 2 times negative 2 become negative 4. 1 times negative 2 become negative 2. Now if I look again, which side is larger? So I have to go to a number line. Minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3. Negative 2 is on the right. So negative 2 is a larger number than negative 4. Okay? So this time round, my inequality changed already. Left larger than right. But when I multiply a negative 2, it will change side. Negative 2 is now larger than negative 4. So when I multiply positive number, multiply positive 2, the sign don't change. But when I multiply negative 2, a negative number, the sign change. Okay? So this will stand true for any number that I multiply or divide. When I multiply a negative number, this sign will change. Okay? So when I'm solving equation, let us go back to our question B. I want to solve this. So again, when I'm solving, my endpoint is x by itself. If I were solving an equality, I have negative x equals to negative 6. What is the thing we'll do? Mia, if I'm solving this, how do I get to my next step? My final step is positive x equals to what, ma? So from here to here, I need to divide by negative 1. Divide by negative 1, my negative x will become positive. Then I know that my x is actually positive x. If I am solving. Okay? So what I do is actually, I divide both sides by negative 1. Then negative become positive. Negative become positive. Okay? So now if I'm solving this inequality, same. I want a positive x. So if I want a positive x, I need to divide by a negative 1. Divide by negative 1. Divide by negative 1. So that I can cancel away the minus sign. Minus minus cancel, become positive. Okay? So for my inequality, negative x divide by negative 1, I will have x. Negative 6 divide by negative 1, I will have a positive 6. So this is also similar to solving an equation. But the only difference is, this time round, it started with negative x smaller than negative 6. But just now, when we look at multiplying a negative number, when we multiply a negative number or when we divide a negative number, this sign will change side. So from smaller than, it is going to change to my left hand side now become larger than my right hand side. Okay? This is the only difference between equation and inequality. When I divide by negative or when I multiply by negative, this thing will change sign. This thing will change side. Arik, only awake when you are playing. Like that cannot. I start with negative 5x larger or equals to 14. If I want to solve, means finally I want only x. But from minus 5x to become x, I need to divide by negative 5. I need to divide by negative 5. And because I want to divide by negative 5 on the left, I need to divide negative 5 on the right also. So when I divide by negative 5, 14 over negative 5. But because I am dividing or multiplying a negative number, my larger or equals to will switch side. It will become smaller or equals to. When we have equals to, it will still have equals to. Just that it from bigger than becomes smaller than. Oh, understand? Don't understand? Which part you all don't understand? Huh? Okay. If we don't do anything at all, do you all know what this line is telling you all? They are telling you minus 5x is larger or equals to 14. Do you all know this line is telling you this? Okay. Then when you are solving, they are asking you, then if I only have 1x, what is the relationship with numbers? What is the relationship between x and numbers? 1x. This is what they want. Solving means I don't want negative 5x, I want 1x. What is the relationship of 1x with numbers? This is what they want. Can? Just like when I'm solving equation, if I have negative 5x equals to 14, this is telling me negative 5x is the same as 14, but what is 1x? Okay? So this one also same. I am given this, negative 5x is larger or equals to 14, but what about 1x? What is the relationship of 1x with numbers? This is what they mean by solving. Okay? So to get to the answer, it is the same as solving for equation. I want to make my left hand side only 1x. So I want to make negative 5x become only 1x. So the step is also the same. From negative 5x to x, I divide by negative 5. If I'm solving equation, I want to divide by negative 5. Okay? If I only look at the left. Because once I divide by negative 5, I will get x. But because I divide by negative 5, that's why I must divide by negative 5 on the right also. then I can know what is x. So this time round also same. When I am solving for inequality, I also want to finally get to 1x. But how do I get from negative 5x to 1x? Also same as equation. I need to divide my left by negative 5 so that I can get to 1x. Okay? Then inequality and equal equation is the same in the sense that whatever I do on one side, I must do the same thing. So I also divide by minus 5 for the numbers. Okay? The only difference is when I multiply or divide by negative number, my sign will change side. So to get negative 5x larger than 14, every of my x must be smaller or equals to 14 over negative 5. This one will give me this one. This line, if I obey this equation, then it will fulfill this equation. It will fulfill this condition. That is the meaning. That is the idea. Okay? Okay? So same if I'm given this equation, I'm asked to solve, means I want to finally have x and all the other numbers put on the other side. I want x to be alone. So from here, if I want x to be alone, I will be dividing both sides by negative 3. Once I divide it by negative 3, I can get 1x. I no longer have negative 3x. I can get a positive 1x. Then the other side will be 20 over negative 3. But because this is a negative number, my sign have to change side. At first, it is left hand side smaller than right hand side. Because I multiply or divide a negative number, the smaller than sign will change to larger than sign. Okay? Then convention, I want to put my x on the left. So, this is the relationship. Even if I put it on the left, the relationship still stands. X must be smaller than 20 over negative 3. So x must be smaller than 20 over negative 3. Huh? Next lesson left 10 minutes only. Okay, another way to show you why the inequality will change side Okay, let's say I start with x larger than 2. Sorry. If I start with negative x larger than 2, when we add or subtract anything, the sign won't change side one. Correct? We add 10. Both sides add 10, then my left hand side will still be larger than the right hand side. Both sides minus 10, my left hand side will still be larger than the right hand side. So, addition and subtraction, it won't change side. Meaning, if I want to change my negative x to a positive x, instead of multiplying, I can do another thing. Item. I can do another thing. I don't multiply. I add x to the left. I add x to the right. Okay? Then I will result in 0 is larger than 2 plus x. Then I move my 2 to the other side. I subtract 2 and subtract 2. Okay? Then can you see that by moving it across, by moving this across, I can also solve. X must be smaller than negative 2. Okay? X must be smaller than negative 2. I started with negative x larger than 2. If I were to divide by negative 1 on both sides, I will have x negative 2. And then I told you we must change the sign. I told you this larger than must change side. Okay? So why? Why must it change side? Because if I don't go by multiplication of negative number, when I just move it by adding, by subtracting, I will get x smaller than negative 2. So if I don't change, I'm wrong already. Okay? Can? Or you all just remember, when I multiply or divide negative number, I must change the side of the inequality. Can? Okay, we look at one more question. I started with 1/10 of k is larger or equals to 2. When I'm solving, means I finally... Hey, hello! Elijah! Next lesson, you sit there. 1 month. Okay. So when I'm solving, I don't want k over 10. I want 1k. Okay? So from this to become 1k, I need to multiply 10. So that my 10 can cancel away this denominator, I will get to 1k. But because I multiply 10, I need to multiply 10 at the same time. To the right. That is how I solve equation. So how I solve equation is exactly how I solve inequality. Multiply 10 at the same time. Then I will have k. Then my right hand side become 20. I multiply a positive number, so I don't need to change sign. So it is still larger or equals to. Okay? So if you know your equation, you have no problem solving inequality one. I do one more. I want to solve this inequality, means finally I want 1p. If I only want 1p, I want this negative 2 over 7 to disappear. So to make this negative 2 over 7 disappear, I multiply negative 7 over 2. I multiply negative 7 over 2. Because negative can cancel away negative, 7 cancel away 7, 2 cancel away 2. So I have to do the same thing on the right. This is how I will solve equation. So it is the exact same way how I will solve inequality. Just that I am multiplying a negative sign. So this smaller than will change side. It will change to larger than. Then I will have 1p already. So negative times negative, positive. 4 and 2 I can cancel away. This one become 1. This one become 2. So 2 times 7, 14. 5 times 1, 5. The number itself, you also can key in this times this into your calculator. Your calculator will tell you 14 over 5. So the important thing is you need to know that when you are multiplying negative number, you need to change sign. Then this is your answer already. I times 7 out of 2 so that 7 numerator, 7 denominator, cancel, become 1. 2 denominator, 2 numerator, cancel, become 1. Negative and negative multiplied together become positive. So I have a positive p. But because I multiply this, so I must multiply the same thing. This whole thing cancel away this whole thing. Okay? I write it like that easier for myself to see. It is actually the same as if I divide by negative 2 over 7. They are the same thing. Dividing 2 over 7, it will also make this disappear. Dividing this by negative 2 over 7, you will get the same number. Okay? So if you know your equation, it is really very easy. Wow. All too easy. Can? Okay, I do another one. No time. Okay. I no time to do means you all have to do for homework. Okay? Okay, homework finish until question 4. Worksheet 1C finish up until question 4.